Hi, hello everyone. This is Dr. Abdul Pasha, Assistant Professor, Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. So here our course is about power system operation and control. So in this today I am going to give session on control center operation of power systems. So this includes some key features which will describe about what are the control center operations that are existing in the power system. So coming to here, the electrical technology was to be found on the remarkable discovery by the Faraday. So that will be changing magnetic flux and creating an electric field. So out of that inventions, it grew to be largest and most complex engineering. So that will make a good achievement for the human being. And electric power system which may indeed with life without electricity, now it should be unimaginable thing. So electrical power system networks forms the basic infrastructure of the any nation or country. So even as we read this, electrical energy is being produced at its rates in the excess of hundreds. So that means which is about gigawatts in nature. So 1 gigawatt should be here, and that gained rotor spinning at speeds up to 3000 rotations per minute brings to us the energy stored in the potential energy of water, which are it may be in the manner of fossil fuels. So we notice that electricity only when the lights are go out. That means when the basic features are introduced for the electrical power system, they have remained practically unchanged in the past century case. That means there are some significant milestones in that evaluations of the electrical power system networks. So here, electrical energy is an essential parameter or ingredient for the industrial as well as all-round development of any nation. So that means it is generated centrally in bulk and transmitted economically over long distances. So that electrical energy is to be converted at very step in the process of generation, transmission, distribution, and also in the case of utilization for the electrical energy. So that electric utility industry is probably the large and most complex industry in the world. Hence, it will be very complex and challenging aspect to be handled by the power engineering. So that should be particularly considered in designing the future power systems that is ready to deliver the increasing amounts of electrical energy. So this calls to the perfect understanding, analysis and decision making of the system. So this power system operation and its control plays a very key role. That means it makes very important tasks in the world of electrical power engineering. That means the power quality is supposed to be characterized by one of the stable AC voltage at nearest to the nominal values and at nearer to the rated frequency that should be subjected to the acceptable minor variations. That means which are free from annoying voltage flickers and voltage sags and frequency fluctuations. So here the main parameter power quality determines the fitness of electric power. So here it will determines fitness to the voltage case, fitness to the current case. Like that it should be follows. That fitness is providing to the entire power system network to operate smoothly. So it may consider some lagging aspects which are fluctuations in voltage or flickers in voltage, sag in voltage, swell in voltage. So these parameters are mostly influencing the power quality aspect. So here one more consideration is about near sinusoidal current and voltage waveforms which are free from higher order harmonics. That means all electrical equipments which are rated to operate at nearer the rated voltage and at rated frequency. That means effects of the poor power quality is going to be considered. So which makes the maloperation of control devices, relays like that it should be follows, and some extra losses are going to be expected. So that may be in the manner of capacitors, transformers, and in rotating machines also. So this fast aging of the equipments may leads to damage to the load cases, and load centers got affected by these parameters. So this may be expectancy of loss production due to the service interruptions, electromagnetic interference factors. This is due to transient effects, power fluctuations which are not tolerated by the power electronic parts. They usually produce distortions in the or fluctuations in the power equipments, which may causes malfunctioning of the equipments. So these electronic components producing any harmonic contents and uneven parameters which are affecting to the wave shape nature. So due to which the response of the system may got affected mostly. So that response cannot be replaced immediately, due to which the load going to be fluctuated unevenly. So this may impact with the entire whole system of the load. So that's why one of the suitable compensating devices are introduced into the system. Compensating devices. For these distortions or harmonics for the particular system. So they may also causes some poor power quality like non-linear loads, adjustable speed drives, traction drives, which are mostly influencing the power system network as interacting with most harmonic contents and deviations or distortions in the power system network. So here some of the parameters they also influence the entire control center operations of the power system, which are maybe due to the start of the large motor loads, excitation of the large motor loads, arc furnaces, intermittent load transients, lightning effects, switching operations, fault occurrences. So these also mostly affecting the system parameters. So here starting of large motors means which may impact the load, and sudden current will changes to the load disturbance cause. So arc furnaces also produced in the manner of I square R coefficient, as one of the heat content is expected, and in between that intermittent load transients. So these intermittent load transients are usually uneven to the expected load variation. So this may also considered as one of the severe effects to the power system. And also this lightning effect from the atmosphere, which are mostly influencing to the line. So this lightning may causes sudden damage of the entire load case. So which influences with huge amounts of voltages. So this effect may leads to damage to the entire load center. So which will generate some thousands of voltages. Thousands of voltages are impacting onto the line. So for this we need to take suitable lightning arresters arrangements to protect the power system network operations. So these may be connected at the substation level or where the expectancy is more with the lightning parameters. There we are going to suppose to keep or install such kinds of operators. And during switching operations also we may expect the affected areas. So uneven switching of the power operators, and even though it may be happens with manual or control operations, that switching operations also leads to damage to the centers. And any sudden cause of fault occurrences, it may be short circuit fault, or it may be due to heavy occurrence of the voltage or current influences. So that may also directly or indirectly affecting the system parameter. And here are some steps to address the power quality issues. So which are in the manner of detailed field measurements, which will ready to monitor the electrical parameters under various places, which will ready to assess the operating conditions. So that should be in terms of the power quality. So we already discussed this parameter. That means we are giving the fitness to the entire electrical power system network. That means we should to be stand in such a manner that ready to assess the operating conditions. So what are the acceptable limits to the power system network, and which should be considered with respect to the electrical parameters. So these are the main key features we must remind before going to run the system usually. And here we will make some detailed studies using some computational models that will make the system to smooth operations. So here the accuracy of the computer model is first ready to build up. That should be to the extent of a degree where the observed simulation values that will be ready to matches with those of the field measurement cases. That means which will provide us with a reliable computer model that will be using with workout with the remedial measures. That means for the purposes of the analysis, we may ready to use the load flow studies, dynamic simulation aspects, EMTP solutions, harmonic effects like analysis based on the harmonic considerations. Depending on the objectives of the studies, we are going to make this system parameters. So here we also evaluate the effectiveness of the harmonic filters, which may ready to attenuate the conditions through the computer model built, and they may ready to pay the attention to any reactive power compensation. So here it is most important aspect for making a compensation in the reactive manner. That means the filters may provide a fundamental frequency for normal system that should be operating under suitable conditions. So the equipment ratings may also consider, and it will also to be addressed to the account for harmonic current flows, and which may ready to consequent overheating of the systems. So here are some of the solutions that should be provided for the suitable power quality operations. That means poor power quality in the form of harmonic distortions or low power factor ready to increases the stress on a facilities of the electrical system. That means which makes the overtime, this may ready to increases the electrical stress, so which will be shorten the lifespan or life expectancy of the electrical equipment. So in addition to that system degradation, the poor power quality can ready to cause a nuisance, one of the disturbance of tripping and unplanned shutdowns that should be happens within the electrical systems. So in an increasingly automated electrical world, it is important for a facility to evaluate the power quality aspects. So even though the system will develop suitable conditions with the harmonic distortions of a low power factor and the presence of other transients. So this makes the transiency to the system which will ready to occupy their insistence, and which may ready to cause the severe damage to the electrical system. So this may provide system analysis and evaluations of the power quality issues and makes recommendations for power system design solutions. So here we will provide some structure to the power system network as in the manner of generating stations, transmission lines, and the distribution systems, which are main components of the electrical power system network. So generating stations and distribution systems are connected through the transmission lines, so which also ready to connect to the power system network as in the grid area to another case. So distribution system will connecting to all the loads in a particular area to the where the power is going to be transmitted. That means directly to the transmission lines we are going to transmit the power in a bulk aspect. So which may be usually high thousands of voltage kVs like that. We are ready to transfer that much of power. So this will describes all the components of the structures of the power system network. So here for economical or technical reasons, Individual power systems are supposed to be organized in the form of electrically connected areas, or it may be taken as regional grids. And as the power systems are ready to increase in size, so it will lead the number of lines as substations, transformers, switchgears, like that. So their operation and interactions became more complex, and hence it is necessary to monitor these information in simultaneous manner for the total system at a focal point, which is called as energy control center. So this is most important, as the entire operations of the power system network is operated from the ECC, that means energy control center. So here the fundamental design feature is supposed to be increases in system reliability, and which makes the economic feasibility of the system. So likewise it is going to operate suitably. So here are some major concerns of the power system design and operation. The first case is about quality. This is much more important. Why? Because the quality of the power is mostly influencing the load operation conditions. That means which makes the continuous at a desired frequency and voltage level. So reliability also operates. That means minimum failures. That makes the rate of components and systems, and which makes the security also. That means which gives the robustness under normal state even after disturbances cases, making the stability aspects, maintaining to the synchronism under disturbances, and also it provides the economy as minimizing the capital investments, running and maintenance cost. So all these factors, starting from quality of the power supply, reliability of the power supply, suitable security or constraints, stability considerations, economical aspects, all these cumulatively makes the control center operations to run smoothly in a given time aspect. So here it should be needed to make the power system management as in the manner of demand for whole power system increasing for day by day, and number of transmission lines are required, providing more substations, and it also considered with equipments of transformers, switchgear equipments, like that it should be follows with some auxiliary components, and operation and interaction is also more and more complex to these systems, and providing essential systems to monitor simultaneously for the whole system at a focal distance or point, so which will providing the energy load center aspect. So this makes the system to be comfort under various conditions. So providing components of the power system to the respective operations means it will be associated with information gathering and making the process, so which gives the decision and control over and integration of the whole systems. So these may takes place with all the aspects, and the energy load center is supposed to be functions for the energy load interface at the required location to control the functions of the coordinating the response in both normal and emergency conditions. That means some of the digital computers, they are very effectively used for the purposes, and their functionality is to process the data effectively, and which will detect the abnormalities conditions like alarm, the human operator by lights, buzzers, screens, like that it may ready to operate, and depending on the severity of the problem, the energy load center ready to accept for all the respective conditions. So here it will makes the control center of the power system to be smoother with one of the human machine interface that will be ready to equipped with CRT presentations. So here this will plays a key role making the presentations with the CRT that gives functionality of the machine very effectively. It gives the entire description with the suitable conditions and providing suitable keyboards that will changing the parameters. And here it also considered with the special function keyboards. That means which will alters or changes the transformer tabs. So we will consider one of the tab changing transformers which will changes the levels of the voltage, and switching to the line capacitors. So all these considerations we must take into the account. One of the light pen cursor that should be ready to open or close to the circuit breakers, and based on that the faulty position or location is going to be isolated, and the alarm lights, alarms in display different sizes and different sounds, and dedicated telephonic communications with the generating stations and the transmission substations, neighboring power utilities. All these cumulatively provides and works for the suitable operations of the power system network. Here are some control features that should be considered from control center that provides the system commands directly, which will gives to operate for mode of control action, and units those are based on peak load conditions, and one of the AGC parameter, that is automatic generation control, is ready to achieve the system parameters, and it also consider the data entry process, providing the alarms which will be ready to find the sources of alarm and giving the necessary action, and the plant or substation selections are most important here. So one of the special functions are ready to provide it, which will make or send retrieve the data again. So with that we can read out the control actions as which will be connected to as output to the CRT or printers, and one of the CPU control is required as selection for the computer aspects. So all these features starting with control center, commanding circuits, number of units which are based on the peak loads, AGC aspects, entry sheets, and some alerting cases, substation levels, functionalities, and control operations makes the system to be suitable to operate under various disordered conditions. So all these cumulatively suitably works to the location at the given case. So here are some of the functions of the control center. Those are short, medium and long term load forecasting. That means which makes the system planning, unit commitment and maintenance of schedule. That means giving to the security monitoring case, state estimation case, economic dispatch case, and also load frequency. So here it makes the system over to work out at various conditions. It may be due to low frequency control case or economic dispatch case. The unit commitment problem maintains the scheduling means under certain conditions the state estimations are followed for suitable economic dispatch conditions. So here one of the new system introduced into the power system network, that is SCADA. So that is supervisory control and data acquisition systems. So that means this space one of the key process, that means this will ready to make the ability to monitor for entire system in real time conditions. That means this is facilitated by data acquisitions, which will including meter reading, checking statuses of the sensors, which may also considered one of the IoT technologies, that is Internet of Things, etc. like that. So these are communicated effectively at regular intervals, that is based on the system constraints. So a well planned and implemented SCADA system not only helps to utilize the deliver power reliably and safely to their customers, but it also helps to lower the costs and achieves to the higher customer satisfaction. And it also makes the retentions of the power system network. So why we require SCADA system? What are the benefits or features over this system that we are going to learn? And if we did not having the SCADA system, what happens means we would have some inefficient use of human resources. We are not utilizing effectively the wastage that should be taken place. So this would cost in rupees or lakhs of rupees and crores of. So in today's restricted environment of SCADA, it is very much critical in handling the volume of the data needed. That means that should be considered in a timely aspect or timely fashion. So service restoration that should ready to involve in travel time, and would be significantly much more higher. So it is essential to maintain the reliability case. Without that, we cannot make the system to be sure of. So here it provides one of the architecture for SCADA system, which will be considered with basic elements like sensors, which will ready to measure the desired quantities. So they can be done by one of the current transformers, that is CTs, which will measures the currents, and potential transformers are ready to measure the voltages. And nowadays there is a whole process with new breed of intelligent electronic devices. Those are called IEDs. These are the latest technologies in the electronic system. So this data is given to a remote terminal unit called RTU. So RTU sensor. So the master of the computer or unit that will be resides at the control centers by EMS keys. So as SCADA process is going to be taken place, master unit scan RTUs are for reporting purpose, and it reports to the existing conditions like RTU sends back the data and it will masters the computer places in its memory case. So the whole memory is occupied with these sensors feeling the response of the system. So in some new aspects of the substation architectures or models, there should be the significant local processing of the data which will ready to be sent to the control area. So the data that is displayed on CRTs or printed with the SCADA that may be taking as one of the logging process system. So this make the sure of the system considerations to the respective locations. So this SCADA is ready to provide a complete log of the system. That means the log could be provided for the entire system or part of the network. So which may gives the type of the information provided. So which may consider under time of the event, circuit breaker status, current measurements, voltage measurements, calculated flows and energies. These are going to be taken. Line and equipment ratings also much more important to control the operations. So likewise, we can maintain the SCADA operations as the continuity for the upcoming classes, and which will make the smoothing operations of the power system at the various locations. So these are some of the references that I have taken, and thank you.
Like, share, and subscribe. Hit the bell icon for more updates.